Hello there, and welcome to the Quiet Universe channel. I'm so glad you found your way here. Maybe you've had a long day, or maybe you're the kind of person who likes drifting to sleep with gentle thoughts of cosmic mysteries. Either way, tonight's journey is for you. You have nothing to do now but rest. Let your mind relax, your breathing slow, and your body grow light, as if gravity itself has softened. Because tonight, we're not just stargazing. We're exploring the quiet mysteries of the universe, all in a calm and dreamy way. As we begin, know that you are part of this story. The atoms in your body were born in stars long ago, and someday, far in the future, they will return to the cosmos. The universe will continue unfolding, stars will shine and fade, and new wonders will emerge. All you need to do is listen softly and float along. And just before we start, if these calm, curious explorations help you unwind at the end of the day, consider leaving a like or subscribing. It helps other sleepy souls find their way here too. Now, let's begin. When you gaze up on a clear night, you see darkness between the stars, deep black pockets of night. And yet, our universe is filled with countless stars. Why isn't the sky ablaze with light? This simple question puzzled thinkers for centuries. In an infinite, ageless universe full of stars, every direction ought to land on a star's bright face. The night sky should glow like the sun, with no gaps of darkness. But it doesn't. Instead, it's mostly silence and dark. This contradiction is known as Fermi Paradox, a mystery first noted hundreds of years ago. The solution arrived when we learned something profound. The universe is not infinite and eternal. It had a beginning, and it is expanding. In 1929, astronomer Edwin Hubble observed distant galaxies drifting away from us. The farther a galaxy is, the faster it recedes, as if space itself is stretching. This told us that the cosmos is dynamic, growing larger over time, and it must have been much denser and hotter in the past. From these insights, the theory of the Big Bang was born, the idea that the universe began as a tiny, brilliant burst of energy about 13.8 billion years ago. Because the universe has a finite age, we can only see so far. Light has a speed limit, and in 13.8 billion years it has traveled a vast but limited distance. That means there are stars and galaxies beyond our horizon whose light simply hasn't reached us yet. Beyond a certain distance, the universe is effectively hidden from view, not because it isn't there, but because it's too far for light to have arrived. There's another reason the sky is dark at night. As space expands, the light from the most distant stars and galaxies gets stretched out, changing its color and energy. By the time it arrives here, it may no longer be visible to our eyes. Starlight that began as fierce blue or white gets redshifted into gentle infrared or radio waves, a glow we cannot see without special instruments. So, even though the universe is full of light, much of it is invisible to us, diluted, stretched, and dimmed across the eons. In fact, when we peer deep into space, the farthest light we can detect isn't from a star at all. It's a faint, cool radiance known as the cosmic microwave background, the afterglow of the Big Bang. This light comes from a time before any stars had formed. It's everywhere, pouring in from all directions, but it's so stretched out by expansion that it's not visible to human eyes. Instead of blinding us, it's more like a soft whisper from the infant universe. The darkness of the night sky, paradoxically, is evidence that the universe had a hot, bright beginning, a beginning whose light has now faded into a gentle murmur. The universe is continuing to expand today, and not just at a steady pace. The expansion is speeding up. Some mysterious force, which scientists call dark energy, is pushing the cosmos outward, making distant galaxies recede faster and faster. Over incredibly long timescales, this accelerating expansion will deepen the darkness of the night sky. Galaxies that are now visible in our telescopes will slip away, one by one, beyond the cosmic horizon. Space can even expand faster than light, since it's space itself growing, not objects moving through space. Thus, there are galaxies so far away that their light will never reach us, no matter how long we wait. They are effectively beyond the observable universe, forever out of reach. Right now, we live in what might be called the cosmic morning, a time when we can still see many other galaxies and the afterglow of the Big Bang. But this won't always be so. Trillions of years from now, if there are astronomers, they might find the sky almost empty. It's estimated that in about 100 billion years, virtually all galaxies outside our local cluster will have disappeared from view, swept away by expansion into darkness. Future beings could look up and see nothing but the stars of their own galaxy, islands of light in a vast black ocean. They might not realize other galaxies ever existed. They'd have no easy way to know of the Big Bang or the cosmic web of galaxies. Those clues will have vanished into the dark. We, however, are fortunate to exist now. We can see the universe in its youthful splendor, rich with galaxies near and far. We have evidence of our cosmic origins written in light, available to study and marvel at. In the very far future, the universe will keep its secrets closer. Now, let's come a bit closer to home, to the sky above the moon. When astronauts visited the moon, they found a sky very different from Earth's. Up there, even when the sun is shining, the sky is pitch black. In all the photos from the Apollo missions, the lunar sky is a pure void, with no stars to be seen. Some found this puzzling. Shouldn't the stars blaze even more clearly without an atmosphere? But the absence of stars in those photos has a simple explanation. On the moon's day side, the sun's unfiltered light is so strong that it overwhelms the feeble light of distant stars. The astronauts' eyes, and their cameras, were adjusted for the bright lunar surface lit by sunshine, which made them effectively blind to the delicate starlight around them. It's not that the stars weren't there. It's that in the flood of sunlight, their gentle glow was drowned out. On Earth, during the day, our sky turns blue, and we see no stars because our atmosphere scatters sunlight, creating a bright veil. The word atmosphere literally means a sphere of vapor, a sky-blue shell that hides the stars. But the moon has no atmosphere to scatter light, so its sky stays an inky black, even at noon. If you were standing on the moon in the sunlight, you'd see a black sky with a blindingly bright sun, a stark, beautiful contrast. And yet, unless you were in shadow and let your eyes adjust, you'd still see almost no stars, because the lunar surface around you glows brilliantly under the sun's rays. One Apollo astronaut reported that by standing in the shadow of the lunar module and lifting his visor, he could finally see some of the brightest stars. Imagine that, floating in darkness, the surface around you glowing gray, and above, at last, a few diamond-bright stars piercing the blackness. If Earth had no atmosphere, our daytime sky would look much the same, a black backdrop with a fierce sun. And if the sun set, the sky would instantly fill with stars, without our air's faint glow to wash them out. Our air is a blessing for life, but it hides much of the cosmos from our sight. Even on a crystal-clear night, far from any human lights, the human eye can only see about 3,000 stars twinkling above. Under a full moon, that drops to a few hundred. Out of the Milky Way's hundreds of billions of stars and the universe's trillions of galaxies, we see only a tiny handful of pinpoints. It reminds us how limited our senses are and how much more is truly out there. For this reason, astronomers dream of building observatories in space or on the moon. Imagine a telescope on the moon's far side, where it's always night and utterly silent. With no atmosphere and no earthly radio noise, we could gaze into the universe with unparalleled clarity. The stars would never twinkle there. They'd shine steady and clear. We could peer deeper into the cosmos, perhaps catching sights we've never seen from Earth's surface. One day, maybe, we'll have such a lunar observatory, giving us a new window on the universe's mysteries. Speaking of mysteries, One of the greatest questions we ask is, are we alone? In the vastness of the cosmos, it's very likely we are not alone. The sheer number of stars, each potentially with planets, is mind-boggling. Even if life is rare, there are so many opportunities for it to arise. As the famous physicist Albert Einstein and many others have noted, the universe is too immense for life to have happened only here on Earth. In our own Milky Way galaxy, there are an estimated hundreds of billions of stars, and beyond that, hundreds of billions of galaxies. It seems almost inevitable that somewhere among all those worlds, life has taken root. Perhaps simple life, perhaps intelligent life. A recent survey found that most people believe in the existence of extraterrestrial life. We can just feel in our bones that the cosmos ought to be teeming with living things. And scientists largely agree. Many astrophysicists are convinced that the odds strongly favor life, even intelligent life, emerging in multiple places. Some experts are bold enough to predict we might find evidence of alien intelligence within the next few decades. It could be a signal detected by our instruments or microbial life found in a nearby star's planet. But either way, it's a thrilling possibility that within our lifetime we might know we're not alone. Life, as we know it, comes in a dazzling variety, even just on Earth. From tiny microbes under the ice, to trees, to humans. So life elsewhere could be incredibly diverse. Imagine alien creatures adapted to their unique worlds, maybe floating beings in the clouds of a giant planet, or intelligent amphibians in a warm ocean, or forms we can't even picture. Some extraterrestrial life might be simple, like the bacteria and tiny organisms that dominated Earth for billions of years. Others might be as advanced compared to us as we are compared to jellyfish. The universe could host civilizations at all stages of development. There might be civilizations just starting out, using simple tools or discovering fire on distant planets. And there might be ancient societies millions of years older than ours, with knowledge and technologies that would seem like magic to us. To help imagine the levels of advancement, scientists sometimes use the Kardashev scale. This scale, proposed by astronomer Nikolai Kardashev in the 1960s, categorizes civilizations by how much energy they harness. A Type 1 civilization would use all the energy available on its home planet, every drop of sunlight, every gust of wind, every tide and resource, fully powering its societies. They might even control planetary forces like weather or earthquakes to some degree. Humanity is not there yet. We're often estimated to be around 0.7 on this scale, not even a full Type 1. If we continue advancing, perhaps in a century or two we could reach Type 1, becoming true planetary stewards of Earth. A Type 2 civilization goes beyond its planet, tapping into the energy of its entire star. This is almost the realm of science fiction for us. It might involve building something like a Dyson sphere or swarm, a megastructure surrounding a star to capture most of its light. A Type 2 civilization would essentially wield the power of a sun, using it to fuel who knows what magnificent projects. Then there's Type 3, which is truly breathtaking, a civilization that harnesses the energy of an entire galaxy. They might travel freely from star to star, use the power of billions of suns, and possibly even manipulate black holes or other exotic objects to meet their needs. To us, a Type 3 society would be nearly godlike, their technology and knowledge spanning the galaxy. Some thinkers have even speculated about a Type 4, one that could utilize the energy of the whole universe, or perhaps even create new universes. It's an almost mystical idea. Such beings would operate on scales far beyond our comprehension. By these measures, we humans are very young and small. We haven't even achieved full control of the energy on our own planet. But we are climbing slowly upward. Reaching Type 1 will require major advances, likely fusion power, complete shifts to renewable energy, and global cooperation on an unprecedented level. It might mean the ability to stabilize our climate intentionally or prevent earthquakes and volcanic eruptions. In essence, safeguarding and managing our planet with wisdom. That's perhaps centuries away, if it ever happens, but it's a hopeful thought that one day we could be wise shepherds of Earth, living in balance. If we look further ahead, to Type 2 and 3, we're peering into the far future, or looking at hypothetical extraterrestrials. Communication for such advanced civilizations might be as different as smoke signals are from smartphones. A Type 2 or 3 might not use radio waves at all, which we use now for TV, radio, etc. They could use gravitational waves or quantum entanglement or other means to send messages instantly across vast distances. They might network entire star systems in ways we can't even detect because we don't know what to look for. Meanwhile, here we are, a budding Type 0.7, still using pretty simple methods to reach out. We've made some charming first attempts to announce ourselves to the cosmos. In the 1970s, we launched the Pioneer 10 and 11 probes out of the solar system, each carrying a small golden plaque. On these plaques are engraved figures of a human man and woman, a map of our solar system, and a diagram of our location in the galaxy. The idea was that if an alien civilization ever found these tiny spacecraft drifting in space, they would know who sent them and maybe know how to find us. It was humanity's first physical hello to the universe. A few years later, in 1977, we launched Voyager 1 and 2, which are now the farthest human-made objects in space. Each Voyager carries a golden record, essentially a time capsule LP. On it are sounds of Earth, waves, wind, animal calls, laughter, music from different cultures, and spoken greetings in dozens of languages. There are also pictures encoded on the records, showing scenes of life on Earth. It's a beautiful gesture, a snapshot of our world cast into the galactic ocean, meant to say, this is who we were, in case you find this. The Voyagers are expected to wander for billions of years. Voyager 1 is over 14 billion miles from home now, leaving our solar system for the space between stars. The chances of these probes ever being found are extremely tiny. Space is enormous, and the probes are so small. But in a way, that's not the point. The point is that we tried, that we thought beyond ourselves. They carry our hope and curiosity out into the universe, like messages in a bottle floating on a cosmic sea. While those messages travel outward, we've also been listening carefully for any incoming messages. For decades, scientists with the SETI project have aimed large radio telescopes at the sky, listening for whispers from the stars. Space is filled with natural radio noise from stars, nebulae, pulsars, and even the afterglow of the Big Bang, so one trick is to look in a relatively quiet part of the spectrum. There's a concept nicknamed the water hole frequency band. It's a range of radio frequencies around 1420 megahertz, which is naturally quiet except for a signal from neutral hydrogen, the most common element. Some scientists figured that any intelligent beings might also pick this quiet channel to send their hailing signals, thinking others might be listening there too. It's like choosing a clear frequency on a radio dial so your message isn't lost in static. So far, we haven't caught any unmistakable calls from ET, but we have heard a few strange sounds that made us sit up and take notice. One challenge, of course, is that even if we receive a signal from another civilization, understanding it is another matter entirely. Communicating with an alien intelligence could be the greatest puzzle we ever face. We only have to look at life here on Earth to see the problem. Different species communicate in wildly different ways. Whales sing in patterns we're only just starting to decipher. Bees dance to convey messages about flowers. Cuttlefish and chameleons change colors to express themselves. If we didn't know those were communications, we might miss them entirely. So what if an alien message isn't written in radio waves and images like we expect? What if it's encoded in some chemical signals, or bursts of neutrinos, or something we haven't even conceived of? And even if we detect the signal, how would we translate it without a common frame of reference? When linguists decipher ancient human languages, they often rely on a bilingual text, like the Rosetta Stone, or shared contexts, things we know that can anchor the meaning. But with an alien message, we might have no context at all. It would be like hearing a language with no relation to any human tongue, describing concepts we might not understand. We might not even know if they're saying hello, or listing numbers, or talking about their weather. Some scientists imagine trying to explain something like, "I'm taking a selfie with my drone," to a squirrel. The poor squirrel lacks all the reference points. What is a camera? What is flying? What is self in that sense? That's what it might be like for us receiving an advanced alien communication. One hopeful strategy is to use mathematics as a common language. Math is the same everywhere, we assume. The principles of arithmetic, geometry, prime numbers, and physics should be consistent across the universe. 2 plus 2 equals 4, whether you're on Earth or on a planet orbiting Alpha Centauri. So one idea is to start a conversation by exchanging universal truths. For example, send a sequence of prime numbers, 2, 3, 5, 7, 11, or a simple equation or physical constants. In 1974, scientists sent a brief encoded message from the Arecibo radio telescope towards a star cluster. It included things like the numbers 1 to 10, the DNA double helix structure, and a stick figure of a human. The thought was that any intelligent receivers would recognize the mathematical patterns and know the message was artificial, not just noise. Even if we managed to exchange basic information, true conversation might be incredibly slow and difficult. We might send a question and wait dozens of years for a reply, if the civilization is, say, 50 light years away. And when we get a reply, interpreting it could take even longer. It could be the work of generations to decode an alien library of information, if it ever happens at all. It's a humbling possibility that contact might not be a clear, "hello, here we are" moment, but a long, painstaking process of learning to understand each other. And if the aliens are much more advanced than we are, they might communicate in ways that are beyond our understanding entirely. They may have long abandoned vocal speech or writing. Perhaps they communicate through direct transmission of thoughts, or in dimensions of physics we haven't discovered. Some thinkers, like the astronomer Carl Sagan, pointed out that any civilization capable of contacting us is likely far older and more advanced than us, because human civilization is still very young on cosmic timescales. This raises an interesting point. Would they even see us as worth talking to? It's possible they might observe us the way we observe wildlife, with interest, but not necessarily a desire to chat. This idea is part of the zoo hypothesis. It suggests that advanced aliens could be purposefully not contacting us to allow us to grow naturally, much as zookeepers try not to disturb animals in a preserve. Maybe Earth is under some kind of interstellar quarantine until we reach a certain level of technological or ethical maturity. It's a speculative idea, but it's one way to answer the famous question posed by physicist Enrico Fermi in 1950. Where is everybody? Meaning, if the universe is full of life, why haven't we found any evidence of it yet? There are many possible answers to this Fermi paradox. Maybe life is common, but intelligent life is exceedingly rare. Maybe many civilizations self-destruct or go quiet before they can reach out. Or perhaps they're out there, but we're not listening in the right way. It could even be that they are sending signals, but we fail to recognize them as artificial. Our technology and understanding might be too rudimentary, like a radio that can't tune in to the right frequency. In fact, we have detected unexplained signals from the depths of space, fast radio bursts, odd periodic pulses, and so on. And while most have natural explanations, a few remain puzzling. It's not impossible that among the cosmic noise, there have been messages we missed or dismissed. One of the most intriguing signals happened on August 15, 1977. a radio telescope at Ohio State University, endearingly called Big Ear, was scanning the sky when a strong, unexpected signal blazed through. It lasted for 72 seconds and was about 30 times stronger than the background noise at that frequency. The computer recorded it as a string of numbers and letters, signaling its intensity. When an astronomer named Jerry Eman looked at the printout, he was so surprised that he scribbled "wow" next to it, and that's how it got its famous name, the wow signal. The wow signal appeared to come from the direction of the constellation Sagittarius. It wasn't an Earth-based interference, as far as anyone could tell. It really did come from space. It had the kind of profile they expected an artificial, intentional signal might have. Naturally, this caused a lot of excitement. Could it be that for 72 seconds we caught a beam from an alien transmitter? After the initial detection, astronomers repeatedly searched the same region of sky, hoping the signal would come back, but it never did. The wow signal stands as a tantalizing one-time mystery. It might have been a technical glitch, or an undiscovered natural radio source doing something weird for a moment. But we can't say for sure it wasn't a call from someone out there. To this day, it remains unexplained. A whisper from the stars that said hello, and then faded, leaving us with more questions than answers. What would it take for us to truly know we've detected intelligent life? Probably a repeated signal, or a pattern that clearly isn't natural, something that encodes information in a way we can't chalk up to astrophysics or coincidence. The wow signal, enticing as it was, didn't repeat. Without repetition or additional data, we can't decode it or be certain of its origin. It's like hearing a strange noise in the dark. It could be someone trying to speak, or just the house settling. You need to hear it again to be sure. So scientists keep listening, improving their methods, scanning more frequencies and more parts of the sky. Thousands of star systems have been monitored for artificial signals, and the search grows more sophisticated each year. If the universe is as lively as we suspect, then surely out there are many worlds with their own stories. Some might have simple creatures swimming in alien seas under pale foreign suns. Others might have civilizations far older than ours, quietly watching the stars, or even exploring their galaxies. Maybe they've seen our little yellow sun from afar and wondered about us in return. Is anybody out there? It's a question that can make you feel wonderfully small and connected at the same time. The night sky doesn't give any easy answers, but the possibility is enough to inspire awe. The first time we truly know we're not alone, if it happens, will likely be a history-changing moment. It might come via a faint signal in a radio dish, or a telescope image of biosignatures like oxygen or chlorophyll on a distant exoplanet's atmosphere. However it comes, it will expand our perspective profoundly. It will no longer be our world and the empty universe. It will be one inhabited universe. We'll have to share the cosmos in our minds with others. It could unite humanity in new ways, realizing that in the end, all humans are one tribe among the stars. It might also bring deep questions. How would we respond? What would we say? How would it affect our religions, our philosophies, our daily sense of significance? These are peaceful thoughts to ponder as you drift to sleep, imagining that one day the silence will be broken by a friendly hello from the darkness, and we'll know for sure what we have long hoped. We are part of a larger community among the stars. But even without aliens to talk to yet, the universe offers endless other mysteries that spark our curiosity. Our own cosmic neighborhood has given us puzzles, planets and stars doing things we didn't expect. Sometimes things we discover seem to vanish before our eyes, reminding us how dynamic and surprising space can be. One such mystery unfolded around a bright star named Fomalhaut, just 25 light-years from Earth, practically next door in cosmic terms. In 2004, the Hubble Space Telescope took a remarkable image of this star. The picture showed a huge ring of dust encircling Fomalhaut, and a bright dot inside that ring that appeared to be a planet. This was one of the first times we directly saw an exoplanet, a planet around another star, in a photograph. The planet was unofficially nicknamed Dagon. It caused quite a stir. Here was a world we could actually see as a little point of light. Dagon seemed to orbit at the edge of Fomalhaut's dust disk, and initial estimates suggested it was a few times the mass of Jupiter. Yet, from the very beginning, Dagon was strange. It was unexpectedly bright. So bright, in fact, that some scientists thought it might have a big system of rings or dust around it reflecting lots of light. It also didn't show the kind of heat signature a young massive planet should. It didn't glow in infrared as expected. Over the next few years, they continued to observe it. Instead of a steady, planet-like path, Dagon appeared to change. It got dimmer, and its shape in images looked more spread out. By 2014, when they looked for Dagon again, it had vanished. The planet was simply gone from the pictures. You can imagine the confusion. How does a whole planet disappear? After careful analysis, astronomers came to a startling conclusion. Dagon was never a solid planet at all. The best explanation is that it was a cloud of dust, the aftermath of a titanic collision in the Fomalhaut system. Two large bodies, perhaps the size of asteroids or small moons, likely smashed into each other near the outskirts of that system. The impact would have been catastrophic, grinding a huge amount of material into fine dust. At first, right after the collision, that dust cloud was dense and compact, reflecting a lot of light, enough to look like a shining point, hence a planet in Hubble's eye. But over time, the debris cloud expanded and dispersed along the orbit. As it spread out, it became fainter and harder to see, until it essentially disappeared from view. Catching this event was an incredible stroke of luck. Such collisions in another solar system might happen only once in many hundreds of thousands of years, and we just happened to be watching at the right decade. It's a bit like looking at a quiet pond and randomly witnessing a big splash, except on a scale of planets. This vanishing planet taught us a lot. It gave scientists a chance to see what the aftermath of a planetary collision looks like. In fact, our own moon is thought to have formed from a giant collision billions of years ago between the young Earth and a Mars-sized body. By studying the dust and how it behaved in the Fomalhaut system, we glean clues about how planetary systems evolve and the kind of chaotic events that can shape them. The case of Dagon turned out not to be a planet mystery, but a collision mystery, and it showed that even a careful observation can fool us if we don't have the full picture. And Dagon isn't the only time astronomers thought they saw something, only for it to vanish later. In 2012, there was great excitement over a planet announced around Alpha Centauri b, one of the stars next door to us. Alpha Centauri is the nearest star system to the Sun. The planet, called Alpha Centauri bb, was detected by the subtle gravitational wobble it induced in the star, a common method of finding exoplanets. It was touted as the closest exoplanet ever discovered, a potential Earth-mass world practically on our doorstep. But a few years later, further analysis showed that the signal might have been just a quirk of the data, essentially a mistake. After rechecking, many scientists concluded that Alpha Centauri bb probably doesn't exist. The initial data were too noisy, and the detection was a false positive. It was a sobering reminder that science can be tricky and that extraordinary claims need extraordinary evidence. That planet quietly disappeared from the catalogs, and the search for real planets around Alpha Centauri continues. Now consider something even more dramatic. Not a planet, but a star that vanished. In a galaxy about 75 million light-years away, there was a peculiar star known as a luminous blue variable. A type of very massive, very temperamental star that shines millions of times brighter than the Sun and goes through unpredictable fluctuations. Astronomers observed this star between 2001 and 2011, noting its eruptive, volatile behavior. These kinds of stars can brighten and dim erratically as they shed material. It was expected that at some point, perhaps in thousands of years, it would likely explode as a supernova, as is the fate of many giant stars. But when they pointed a large telescope at its location in 2019, the star was simply gone. No brilliant supernova had been recorded. It just wasn't there anymore, at least not in visible light. This was a real head-scratcher. Stars don't usually just vanish. If they die, they go out with a bang, supernova, or end as a slowly cooling ember, like a white dwarf, that we can still see. What could have happened? Astronomers have a couple of theories. One is that the star did have some kind of outburst, but instead of exploding, it belched out a lot of gas and dust, which formed a thick shroud around it. In this scenario, the star might still be there, hidden behind its own curtain. The dust could be so dense that it blocks the star's light, making it effectively invisible to us. If that's the case, the star might reappear someday if the dust dissipates, or if we look in infrared light, which can penetrate dust, and catch its glow. The other possibility is even more intriguing. The star may have collapsed directly into a black hole without a supernova explosion, a so-called failed supernova. Recent research suggests this can happen for the most massive stars. They reach the end of their life, and instead of a grand explosion, they implode, with most of the star falling into the black hole it forms. There might be a brief flash of light or a burst of particles, but not the enormous blast we normally expect. If that is what happened to this star, it would be one of the very first times we've ever observed such an event, or rather, not observed, since it's the lack of star that we see. It means we caught a star in the act of quietly winking out of existence, leaving behind only a dark remnant. Either way, cloaked star or direct collapse, the case remains unresolved. Astronomers are actively seeking more data, for example, looking for any faint X-rays that might indicate a feeding black hole, or waiting for the dust to clear if it's hiding. Until then, the missing star in galaxy PHL 293b, as it's cataloged, is an intriguing cosmic mystery. All these tales, the disappearing planet, the phantom exoplanet, the vanishing star, show us that the universe still holds surprises that can confound even experienced scientists. It keeps us curious and humble. Just when we think we have things figured out, we discover something that makes us say, that's funny. What's going on there? And sometimes the solution, when it comes, is just as astonishing as the mystery. Mysteries aren't limited to faraway stars and galaxies. We've encountered them in our own space exploration adventures as well. Let's drift now to the edge of our solar system, where in the 1970s, two brave little probes, Pioneer 10 and Pioneer 11, were sent out into the unknown. These were trailblazers, hence the name Pioneer. Pioneer 10 was the first to fly past Jupiter and venture beyond Mars. Pioneer 11 followed, passing by Saturn as well. After their planetary missions, both Pioneers headed out toward interstellar space, carrying their golden greeting plaques. As the years went by and we tracked these probes, engineers noticed something odd. The Pioneers were slowing down just a tiny bit more than expected. Spacecraft moving away from the sun should decelerate due to the sun's gravity, but in this case, the deceleration was slightly excessive. It was as if some subtle force were pulling them back, ever so gently. The effect was minuscule, on the order of a 10/1000th of Earth's gravity, but over the vast distances the probes traveled, it added up. By the time they were billions of miles out, the Pioneers were a few thousand kilometers off from where our calculations said they should be. That might sound like a lot, but relative to the journey, over 10 billion kilometers, it was a tiny discrepancy. Still, it was a real puzzle, detectable in the Doppler data from their radio signals. This became known as the Pioneer anomaly. For a long time, the Pioneer anomaly defied explanation. Scientists wondered if there might be something new in physics at play. Perhaps a slight deviation from Newton's law of gravity at large distances, or maybe an influence from dark matter or unknown forces. They analyzed everything: the gravitational tugs of all planets, the pressure of the solar wind, even whether the expansion of the universe could cause such an effect. Nothing straightforward could account for it. Finally, after years of detective work, a team of diligent researchers solved the case, and it turned out to be something rather ordinary, yet easy to overlook. The pioneers were powered by radioactive generators, RTGs, which produce heat, and they also had onboard electronics that generated warmth. This heat was radiating away into space, but not perfectly symmetrically. The spacecraft weren't like a uniform ball. They had parts and shapes that caused more heat to be emitted in one direction than another. It turns out the pioneers were emitting a tiny bit more infrared radiation backward away from their direction of travel. And by Newton's third law, action and reaction, if they're shining light backward, there's a small push on the spacecraft forward, or vice versa. In this case, the effect was like a faint drag slowing them, depending on orientation. In essence, the pioneers had miniature photon thrusters, not by design, but as a byproduct of their warmth. This effect was so small that it took a lot of careful modeling to confirm. But when the team included all the sources of heat and how the spacecraft was built, the anomaly matched the calculations perfectly. Even the detail that the deceleration stopped after a while made sense. The pioneers' plutonium power sources were decaying and cooling, so eventually there was no more excess heat to cause the effect. And indeed, the pioneer anomaly ceased once their power ran down. Mystery solved, not by new physics, but by a tiny thermal quirk of the spacecraft. It's rather poetic that after all the grand speculation, it came down to warmth, the faint pressure of heat photons gently nudging our far-flung messengers. Yet, as one mystery finds closure, another sometimes arises. Engineers and scientists noticed another small oddity. During some gravity assist maneuvers, when spacecraft fly past Earth to gain speed, using our gravity as a slingshot, the spacecraft didn't behave exactly as predicted. A few of them gained or lost an extra few millimeters per second of speed, beyond what our calculations said should happen. This is called the flyby anomaly. It's been observed in a handful of cases. For instance, when the Galileo spacecraft swung by Earth in 1990 on its way to Jupiter, its speed after the flyby was about 4 millimeters per second higher than expected. A similar thing happened with the NEAR spacecraft on its way to an asteroid. It got an excess speed of about 13 millimeters per second after an Earth flyby. The Rosetta probe and others also showed tiny deviations. These differences are very small. A few millimeters per second is nothing for a spacecraft going many kilometers per second, and they don't always occur. Some flybys showed no anomaly at detectable levels. But they're puzzling, and as of now, not fully explained. Scientists have considered a variety of causes. Could it be something about how we calculate Earth's gravitational field? Earth isn't a perfect sphere. It has lumps and bumps in its mass, mountains, ocean basins, etc., and it's rotating, all of which could, in theory, affect a close flyby. But those factors are well studied and shouldn't produce the observed effect. Otherwise, satellites orbiting Earth would show it too, which they don't in the same way. Some have wondered if it's related to how Earth's rotation and gravity interact, or if the spacecraft's paths through Earth's asymmetrical gravity field cause a slight energy change that we haven't computed correctly. Others have even speculated about exotic possibilities, perhaps a tiny flaw in our theories of gravity that only shows up in certain configurations, or something to do with how the spacecraft's momentum is measured. Another mundane explanation attempted is atmospheric drag, but these flybys are usually high above the appreciable atmosphere, so that's unlikely to be it, and it would generally slow, not speed up, a spacecraft, unless there's some weird effect. The fact that some probes gained speed implies energy was added from somewhere. Could tidal effects from the moon or alignment of planets have a hand? Or maybe a software or measurement glitch? So far, no single theory has confidently settled it. The flyby anomaly remains as a kind of gentle reminder that even something as well understood as orbital mechanics can have its quirks. Researchers continue to investigate, and future missions might include experiments specifically to test for it. There's even a proposal for a dedicated mission to carefully measure Earth's gravity and test fundamental physics. One such concept is called STEP, Satellite Test of the Equivalence Principle, which could also shed light on any anomalies. In all likelihood, we'll eventually find the cause, and it may turn out to be another case of, oh, it was this tiny effect we overlooked. But until then, it's a small open question, a little mystery hiding in the data. Throughout human history, with each mystery we solve, we often end up uncovering more questions. We've learned so much, from the roundness of Earth to the nature of stars, from the existence of other galaxies to the birth of the universe. And yet, by all accounts, we're only at the beginning of understanding the cosmos. The universe is vast, and much of it remains uncharted and unexplained. It's like standing in front of a great ocean. We've dipped our toes and maybe waded in a little, but the depths beyond are immense and largely unknown. Every star, every galaxy, every strange signal or disappearing planet is a piece of a grand puzzle. We have some pieces on the table, but so many are still missing, and we don't even know what the final picture looks like. The mysteries of the universe are, in a sense, infinite. And that's okay. It means we will never run out of things to explore, to wonder about, and to dream of. Tonight, we have drifted gently through 100 quiet mysteries and marvels. From the darkness of the night sky to the possibility of cosmic neighbors. From stars that wink out of existence to whispers of signals from the stars. Each mystery carries its own whisper, its own lesson in patience and curiosity. Think of how far we've journeyed in our minds. We started from simply looking up at a dark sky, and we ended by contemplating the very limits of our knowledge. We traveled from our moon skies to the edge of the observable universe, from the tiniest photon's push on a spacecraft to the broad sweep of galaxies disappearing into darkness. As you lie here, feeling the pull of sleep, remember that you are a part of this grand cosmos too. The iron in your blood, the calcium in your bones, the oxygen filling your lungs, those atoms were forged in stars that lived and died billions of years ago, long before Earth existed. You are made of cosmic dust that coalesced to form planets and life. When you look up at the night sky, or even just imagine it now, you are connected to those mysteries. The light hitting your eyes from a distant star might have been traveling for 1,000,000 years before it found you. In a way, that starlight is a message from the past, a steady beacon saying, "I'm here, and you are not alone in the dark." Now the stars outside, hidden by daylight or clouds perhaps, but they are all the same, begin to fade in your mind as your eyes grow heavy. We have wandered through 100 cosmic wonders tonight, from paradoxes and paradoxes resolved to hopeful questions and thoughtful answers. Let those thoughts now gently recede like a cosmic tide. It's time to leave the questions for another day and let your mind come to rest. Feel the quiet of the night surrounding you. Even as we spoke of galaxies and eons, everything was calm and slow. In this moment, you are safe and at peace. The universe is vast and full of mysteries, but it's also a place of great peace. Silent starlight, soft darkness, the hush of infinite space. Let that silence wrap around you now. Your breathing is easy, your body is relaxed, and you can let yourself drift, just like a spaceship coasting among the stars. Tonight you've been a cosmic traveler without leaving your bed, sailing on the seas of imagination and curiosity. You can let all these images and ideas float away now, knowing they'll be there if you ever want to visit them again. The mysteries will patiently remain, and new dawns of discovery will come. For now, it's okay to let go. There's nothing more you need to do, nowhere else you need to be. Sleep is approaching, soft and inviting. Imagine that you are a small, cozy part of this great universe, perhaps a tiny star glimmering softly, or a drifting cloud in the Milky Way, or just yourself, curled up on Earth, which is itself floating in the quiet of space. Around you, the cosmos turns slowly, but here in your world, all is still. You can close your eyes and feel that gentle stillness. Thank you for coming on this journey with me. I hope you found it soothing and wonder-filled. As you go to sleep, know that the universe watches over you in its own way. The same laws of nature that guide the stars are carrying you into a night of rest. We are all connected under the same sky. Have a good night, sleep well, and dream of the stars. Good night.